大家好，我叫做丁信和，请多多指教。All right, I'm not sure how many people have been to the Ruby Elixir Conf 2018 last year. Oh, a lot of people here. Oh. I think some of you may remember me since I'm kind of like I introduced myself as a founder of a startup at that time, but actually I found myself not good at business at all. So I'm better in coding or something than the business stuff. So I shut down my company and currently continue my undergraduate degree in Japan. So. And some of you may remember me because like I have made some argues on something like X-Diet or something, right? That's because like there's a educational like company that there are two people called Li Xiaolai from Beijing and X-Diet in Taiwan. Like they start a educational company to teach Ruby. But instead of teaching Ruby, they are teaching people how to cheating and reciting code for the interviews or something. So I made some articles to criticize on their behaviors, and it goes quite popular in Taiwan, and I'm quite surprised. Recently, interestingly, is that there are some updates since that Li Xiaolai used to say that for becoming a full stack developer, you should avoid all Microsoft things like C or C++. And I don't know why. C or C++ is something Microsoft. And recently he publishes his like kind of notebook or something and teaching people how to use Visual Studio Code. So obviously, C and C++ is Microsoft and Visual Studio Code is something not. This may be called one Microsoft with respective interpretations. So this is my like avatar of this year. Like you may see that I'm wearing a uniform and holding a book in my hand. And this book is actually Windows internals. Like, right, Windows. So what I'm gonna talking about today, obviously, copyright. Like, anyone know this? This is called Voyager Golden Records. It is actually a kind of CD that sends to the spaceships and trying to send to the universe and let aliens to find us. If aliens could understand what's going on in this CD, that they may probably know there's a civilization called Earth, right? And there's like a lot of different languages recorded in this CD. There are even like Hokkien language recorded in this CD. Like there's a recording called 太空丙语你好你假爸爸我印度兰我假姐 or something. But can aliens actually understand this? I'm not sure. For example, if there's you're a very like intelligent person and there's a dog and barking at you with 50 different languages, could you even understand that? Maybe not. So actually, this is the cover of that CD. So that there's some graphs try to introduce how to read this CD and how to play these records. And these things are so-called metadata. So we all love open source. Open source contains metadata like commands and variable names and everything so that we could easily understand how it works from the perspective of human beings, not from the machine side, right? So, and one other good thing about open source softwares is that you don't need to reinvent the wheel again. Before open source software is becoming popular, that every company have their own frameworks, own everything, and everybody is building the same thing again and again and again. And when GitHub or open source software is becoming popular, that you could finding packages, finding good implementations from other people and use them and modify them and make the world better. But still, there are some things that we may not want to publicize. For example, one of our very big open source platform on this planet, which is written in Ruby, GitHub, is actually closed sourced. And what's more, they provide self-hosted deployment service for enterprise version. It's called GitHub Enterprise, which means that GitHub will send you a virtual machine or something, and you need to enter the keys, and so that you could use it like on your own server instead of the GitHub's public server. But since then, comes great problems. I'm going to introduce some methods to cracking the GitHub source code, which is not legal, but these methods are not discovered by me, or these are very easily to be found on the internet. So please don't sue me, big GitHub. Approach one, that you could replace a binary called RubyConcealer.so. And actually, you could find this method on GitHub. And I know this GitHub gist like maybe 5 or 6 years ago, but it's still working. And it's kind of replacing the function called rbf-eval to rbf-put, which when the GitHub try to decrypt all the code and try to evaluate the Ruby code, and you stop the evaluation point and start putting all the source codes so that you could get the whole code base of the GitHub. But around like GitHub 2.11 or something, GitHub Enterprise 2.11 or something, this method is not working quite well, because like since then the RubyConcealer.so is written inside the Ruby VM somehow, so that if you try to use GDB to find out what's going on inside the Ruby virtual machine, you will find these functions are still there. But if you try to replace that SO, it will become complicated, kind of. But if we inspect the method GitHub do the encryption, it's just a zlib, and XOR on the key. But if you try to use the normal zlib way to decrypt the code, you may find some other problems. Maybe, I'm not sure, the zlib used inside the GitHub Ruby virtual machine is not the standard Ruby standard zlib method. Then how do we deal with that? So instead of using standard zlib, we could just use the Ruby inside the GitHub enterprise virtual machine. So no matter what changes they do to the Ruby virtual machine, it's fine. So you could still dump the whole code. Done. So even GitHub tried a lot of different methods, try to upgrade their system to avoid their source code from leaking. It's still very hard to do so. Then why? Why is Ruby self-hosted deployment that hard? And why is protecting Ruby source code that hard? Because everything we do is kind of reversible operation. Even if that it is hard to like crack this code is illegal, but it's very hard to get the evidence of their illegal behaviors. So this is very hard to make your customers not abuse your code for some purposes. So the core problem is that Ruby requires the Ruby source code to run in production, since it's an interpreter. So no matter what you do, it's actually reversible. Reversible may not be always a very bad thing, because from the view of quantum, reversible computation means less energy consumption in quantum computers, if we could run Ruby in quantum computers. But from the perspective of protecting our source code, we want some information loss. We want our information to be the exact amount that it is able to run. But it is very hard for human beings to read. And there's one day I see a project written by Shopify. It's called the boot snap. What they're doing is that like when you use this project to run your Rails applications, that the first time you require a Ruby file or something, the Ruby virtual machine will try to compile it into a bytecode and they will cache it. And the next time you try to open your Rails application, it will read cache from your hard disk instead of compiling it again. Wait, compile? But how Ruby code is running inside a Ruby virtual machine? Like before, the Ruby code is probably like the Ruby code directly running by the virtual machine. But since Ruby 1.9, there's another thing introduced called bytecode. It is introduced inside YARV, yet another Ruby virtual machine. So what is the Ruby's bytecode? It is actually an instruction set of like 80 different keywords, and it kind of something like a JVM. Or it's a virtual machine that it's a stack machine that you could first compile your Ruby source code into the instruction set, and they will try to do some optimization on the instruction set so that they will run it faster. Wait, so can we use this bytecode to bypass the initialization of the Ruby? I mean, if we compile all of our code into bytecode, is it possible that we could run without our source code in distribution? So if bootstrap is something in JIT, and we want to try something in AOT ahead of time compilation. So in that case, we could not only make boot time faster, but also protect your source code because your source code is not in distribution anymore. So how? And for compiling your Ruby code, it's very easy. You just need to call the Ruby VM instruction sequence compile and send in your Ruby code, and it will give you a compiled binary. But since the binary is very large, so it's better if we use the zlib to do some compression. But before talking about how to run this code, do you know how many different methods to integrate a Ruby file in Ruby? I don't know. There are 4. But maybe you could write something like this. But this is a feature of Ruby. It's possible. But if anyone do this in the production, that's a wow. So instead of this, the general method of loading a Ruby file are require relative, auto load, and load. And some of them are written in C, and some of them are written in Ruby. And more probably it comes like, for example, the require method will have some behavior changes after the Ruby gems loaded. So I try to use the metaprogramming method, like to change the behavior of the Ruby virtual machine itself to do these things last year, and I failed. So I want to try something different. So what if we create a Ruby placeholder? For example, we have a placeholder Ruby file like this. We check the version if the binary code and virtual machine try to run this code is equals or not. Then we do the evaluation of the Ruby binaries, and I hope it works. I'm still fixing the bugs of the demo last night. Let's try. Okay, I'm using the project that was a Game Boy emulator, which was, I think, it was being introduced in RubyConf 2 or 3 years ago. But this is very CPU heavy task, so that if we run, yeah, something like this, it should run the Super Mario World for 7 or 8 seconds boot time. Oh, it's running. Huh? Ah, this is full screen, so it's not going to. So it's something like this. I think there's some bugs in this game since I found that the PPU of the emulator doesn't work quite well, so that there's some problems about the scrolling. You see there's some bugs, but it doesn't matter. We just need a CPU heavy task for the demo. uh, but let's try. I'm not sure if it is works or not. Okay. Go. What? I should change it with a different name. Compiled test demo. Okay. Compiled demo. Let's see what's inside this code. It's like every Ruby file here becomes a placeholder. And the real Ruby file has been compiled into a binary. But let's try if it can work or not. Oh, it crashed. Great. That's why you shouldn't do any live coding in conferences, because it will always become a live crashing. I think I met this problem before. I think is it. I need to add the Ruby gems here because it's using what? It's using a private, some kind of private bundler. So let's do the bundle installer again. Okay, great. Then do the exec. I think this time it should be working. Perhaps. Oh yeah, it's working. Yeah, it's exactly the same thing, same bug. You see. Okay, and let's leave the crash file here, and we'll talking about it later. And actually, we estimate that there are 12% speed up when booting up this Ruby emulator, this Game Boy emulator. There is some kind of side effects, but still, there are a lot of problems. For example, if we want to improve the performance much better, we may probably like install all the gems inside the vendor file, in vendor folder, and we could compile everything inside the vendor folder. So it should be much faster because every dependency is now get compiled. But I tried and failed because like it's the kind of the Ruby gems itself and the bundler will also be compiled. In that case, it's almost impossible to get booted. And one other serious problem is backtrace. If you see the code here, you'll find all the backtrace become these things: compiled 19, compiled 18. That will make you almost impossible to do any debugging in production, which is terrible. So I'm thinking of something much better instead of this kind of like hacks. For example, we could customize our own Ruby runtime, because all the loading stuff, except for that evil stuff, the evil file reading, all the other things should be done inside the load.c file inside our Ruby virtual machine. So if we do some modification to this, as since now this file could load a Ruby file and SO file, like the binary statically connected and dynamically connected, and we could add a new extension for this file so that our own customized Ruby runtime may probably run run the bytecode directly. This is the power of open source, because Ruby virtual machine is open source, so that we could do these things. So we are going to use the power of copyleft to protect our copyright. Sounds guilty. But is bytecode really unbreakable? Definitely not. I think a lot of people may use this Java decompiler. This is something when you have a Java bytecode generated, that you could use this for decompilation. Because even a series of bytecode could be generated by multiple different ways of source code. But it is generated by machine. So the compiler itself have a lot of patterns. So for recognizing these patterns, it's still possible to get our raw code, source code by this kind of the compiler. Then how Java community to solve this problem? They introduced something like the ProGuard. This is something you could change variable names and something inside the bytecode generated, so that we may probably develop similar technologies to the Ruby bytecode, so that we could better protect our code. So it is not always perfect that there is a way that could protect your code, because even it is binary, that some people could read binary. But the problem here is that we want to increase the cost of cracking, so that it will may take longer time, so that even if they have cracked our source code, that maybe a newer version has already been released. So in that case, that maybe hackers will give up, I think. So I think that should be the end of the talk. Is it? Oh, that's strange. Oh no, I made a huge mistake. Yeah.
You finish your talk, or do you want to do some demo again? You probably have like 5 minutes to fix a bug right now.
Great. I think I try to use this stuff to run the Rails application. That it is still, I think it's able to run it, like, but I cannot estimate any like obvious boot time like improvement on the Rails code, since most of the performance stuff are inside the implementation of Rails itself. So in that case, we may need some kind of optimization in all the dependencies instead of the application code written by you yourself. And I'm not sure why this gets that quick.
Is there anything else you want to add, or do you have any questions from the audience? Anybody got any questions?
Anybody have any questions?
No questions?
Wow. Oh, that's terrible. Yeah, thank you.
Does the Ruby metaprogramming poses any difficulties when you try to?
Yeah. I think I should explain it somewhere. I think the major problem of the Ruby meta programming is that some of the core code are directly written in C. And for some C methods that has already been exposed in the Ruby API, in that case, it will be very easy to modify its behavior. For example, we could like check if there's a RBC file existing, and if it exists, that we directly load the file from that. Otherwise, that we could use the original method or something. But other than that, there are some like internal methods directly written in C and doesn't expose any Ruby API. In that case, these methods are very hard to modify. But we could still like kind of do all of these stuffs because these are the only 4 Ruby API exposed for loading files. If you are loading files inside Ruby, there must be one of these 4 functions being called. So that in case of but the problem is that some of them are very hard to implement inside Ruby. I just say like, for example, the require method may have 100 or 200 lines of code for loading. And the trickiest part is that after the Ruby gems gets loaded, like after the Ruby virtual machine initialized, it will change the behavior of this function because it will try to load some meta programming things done by the Ruby gems. So we have to do some more meta programming things on the Ruby gems on the Ruby virtual machine. That's the very hard point of doing this.
Okay. Do we have any more questions?
But I think, sorry, if we directly change the behavior of the Ruby virtual machine inside the C code, there are some methods that was called by all of these 4 functions. So that case, if we change the raw method that loading the Ruby files, it will be much easier to do the modification. Any more questions?
Any more questions?
Okay.
So does that mean your approach will run into problems when the program is using meta programming?
In most cases, it won't. But in some very strange corner cases, especially where it's trying to read some Ruby files other than the original way of the Ruby definition. For example, I think I've met some problems inside the dependency of Rails. There's one, I forgot the name of the gems, try to read a Ruby file as an ERB file. And I don't know why. But they just create a file which is an ERB file with the extension name of Ruby and try to use an ERB like a ERB interpreter to read that file. But in that case, I will scan all the files inside the dependency. So once I find the Ruby file, I'll try to compile it and it will fail. Yeah, that's very hard.
Okay. Do we have a question somewhere there?
I think one more problem is about the environment variables. Things there are a lot of global environment variables. For example, the file name that's provided by Ruby. In that case, during the compilation, some of the metadata would disappear. So for these cases, we will need to do some workarounds to get over that, so that it could run more gems than the toy here.
Okay, great. Well